Well, hello Internet, and welcome to part 6 of my Ultimate Python 3 tutorial. Today we're going to talk about exception handling and how to get more accurate floating point mathematical operations. Now, of course, nobody wants their programs to crash, and we should write code that anticipates bad things a user may enter to cause a crash, and eliminate them, of course. However, sometimes the user may try to access a database that doesn't exist, or simply refuse to follow instructions. And that is where exception handling comes in. Now, through exception handling, we're going to be able to catch an error that would normally crash our program and give the user the opportunity to do the right thing. And now I'm going to provide an example of how we can do so. So in this first example, we're going to ask the user to enter a number, but if they refuse, we will ask again by catching and solving the problem. So what we're going to do here is we're going to say while true. And by giving the while a value of true, that is saying that we will continue cycling with this while loop over and over again until a break statement is reached. So if we expect an error can occur, what we need to do is to surround our potential error with a try block. And this is a try block right there. Now what we will do is ask the user to enter information. We're going to cast our string into an integer, and we will say, please enter a number, right like that. Now what we need to do is throw a break statement inside here, and the only way this will be reached is if they actually enter a number instead of entering something else. So what we'll do then is we will say except. And just to be clear, the reason why an error would occur here is if they enter something that isn't a number, this will not be able to work. We won't, for example, be able to convert the word dog into an integer. That's what causes the error. And the specific error that would be caused is what is called a value error. So we can type that in. And we'll get more into the multiple different exceptions that we can have as the tutorial continues. And we'll say here, you didn't enter a number. And that would be the error message. And then we are going to then give them the opportunity to enter another number. Then what we can do is if we don't have any idea what the exception could possibly be, this is something you should try to avoid, but it is something that's available, so I want to cover it. What you want to do is you'll say an unknown error occurred. And you can type any message in there, obviously, that you would like. And then if we get past this, which means they entered a number, we can then say print, and we can either do something with the number, or we can just say thank you for entering a number. And there we go. And now we can run our program. And it'll say, please enter a number. I enter A. It says you didn't enter a number. Then it asks me to enter a number again. And then I could do something like 67G. Again, you didn't enter a number. Okay, finally 7. Thank you for entering a number. All right, so there's an example of how we can handle a very common problem. And as we continue, we will cover other common exceptions you should know how to catch as well as solve. And now I'm going to present you with a Python problem to solve. So I showed you a new trick you can use with a while loop previously, which is using the statement of true. And now what I want you to do is to implement a do while loop in Python. And how you're going to do that is by using that while true statement along with a break. And basically the rules for a do while loop is that they always execute all of the code at least one time. And then after the first loop, that is whenever we will have our condition, and if it is true, we will continue running, and otherwise we will exit. And in other programming languages, the way a do-while loop is structured is you normally have something like do with curly brackets, followed by just a bunch of code, and then closing curly brackets. Whoops, not this stuff, get rid of that. Closing curly brackets, all right? So that's the normal way of doing a do-while loop. And then this would be followed up with a while statement with a condition. And it would continue to loop as long as the condition is true. Okay? So what I want you to do is to create a guessing game in which the user must choose a number between 1 and 10. that number is going to be 7. And you're going to have sample output that is going to look like this. Guess a number between 1 and 10, and they continue, plugging numbers in there until they actually get it. So, like always, you can go and look at all the code we have in all the previous tutorials to try to solve this. Use Stack Overflow, do whatever you want, and just try your best. And the goal, like always, is to get you to think in new ways and then to understand the final solution. And I'll give you one little hint. You're going to need a while as well as a break statement. Okay, so hopefully you figured that out, and if not, I'm going to provide you the solution right now. So I'm going to say my secret number is equal to 7. I'm going to use my while with the true statement to continue executing until a break statement occurs. Then I'm going to have guess is equal to, convert this this string into an integer. I'm going to say guess a number between 1 and 10. Might as well just copy that, paste that inside of there. Now what I'm going to do is I'm going to say if guess is equal to secret number. Well, in that situation, I will say print you guessed it. And then I will break out of my statement. Otherwise, I will continue executing forever. So we can save that and run it. And you will see, guess a number between 1 and 10. I can go put 1, I can put 2, I can put 4, but when I put 7, it's going to break out and it's going to work. All right, so good stuff. Now, previously, I talked about how floats are inaccurate, and that's true with every programming language. It's not something specific to Python. And if you are not satisfied with 15 decimals of precision in your floating point calculations, then you are in luck. There is something called the decimal module, which is going to provide for more accurate floating point calculations, 28 points by default. And what I'm also going to do is show you a little bit about how you can work with modules. So let's say you wanted to bring in specifically just the function decimal from the decimal module. How would you do it? Well, instead of saying something like import decimal, you would instead, to just get that specific function, you could say from decimal, I want to import the decimal function. Another thing you can do is you can assign an alias. And what that's going to do for you is anywhere you want to reference the decimal function, you can instead define an alias and refer to it as just simply D. So now what we're going to do is we're going to come in here and I'm just going to show you a demonstration. So I'm actually going to show you something a little bit weird about the decimal function. So let's go and let's create a decimal. Then what I'm going to do is I'm going to say plus equal to D and then 0.01. And then what I'm going to do is continue to increment that multiple times. And then after that, I am going to decrement it by everything that was already added to it. And then I can print out our new sum. And you can see your answer here. All right, so you can see that it comes out at 0.00. But I'm also going to show you now how we're going to be able to come in here and get precision beyond 15 digits. And I'm going to show you another way of importing from modules. I'm going to say from the decimal module, import everything. So there's another option for you. And once again, we can go and create sum1. So let's go and let's create it. And now what I'm going to do is go and add up these values. So sum1 plus equal to and decimal. And let's go in here and throw in 16 digits. So I'm going to go 0.0. And by default, it's going to be accurate to 28, just so you know. And we will go and add that to it again. And then we can come in and print to show you the results. And then after that, we can decrement it so I can show you a little bit, something that's a little strange. Still going to give us the same results, but it's going to look a little bit different. And then we can print out our sum again. And if we run it, you're going to see that you get the accuracy that you expected right here. But, whoops, actually I wanted to have this be all 2s. And save it again and run it. And now you're going to see that you get the value of 0. However, this is going to represent how many decimal places you're working with. So that just throws some people off. This is accurate. This is a value of 0 just like we expect. And it will be considered 0 in Python code. Just wanted to point that out. But also wanted to point out the accuracy that you get with using the decimal function from the decimal module. Alright guys, so that is it for this video. Like always, go and check out the code underneath the video as well as the quiz. And in the next video, I'm going to cover strings in detail, and of course, I'll have more problems for you to solve. So like always, please leave your questions and comments below.